Okay, so just a quick example of what can be done with some of the newer steels. Another grade of steels now that have come to the forefront that some of you may be aware of are the high thermal conductivity steels. But if you're not aware of them, I want to at least introduce you to these higher thermal conductivity die steels because they have some benefits as well. These are currently not covered in the NADCA specification yet. This is still something that is a topic of discussion in one of the subcommittees of the Die Materials Committee that deals with the die material specification. Because of the differences in the way these are treated and in the difference in chemical constituency, right now it's not a real good fit. So we're looking at the potential of developing a separate document for the acceptance criteria of these types of materials as well, or maybe just adding in a appendix to the current document to cover these high thermal conductivity steel grades. The three that are most popular that are out there now, one that's been around for a while is Tulox 44. It's provided by International Mold Steel. There is a DHA Thermal, which is a Daido grade, Japanese grade, and then there's HTCS, a couple HTCS grades from a Spanish producer called Revalma. All of these grades are about 30% higher in thermal conductivity at a 400-degree operating temperature as compared to H13. So what that provides for us in terms of opportunities is, again, delayed heat checking, reduced cycle time if it's drawing out heat more quickly. If we're drawing out heat more quickly, we may be able to reduce shrinkage and yield higher properties. The higher the cooling rate, the finer the grain structure, the higher the properties. So what are these steels? Well, they're mostly considered proprietary grades, but you know, we kind of know what's in them, maybe not the exact limits, but some of the information that we had gotten from Daido is shown on this chart, and how they came up with the chemical constituency they have for the DHA thermal, and that's by looking at what the impact is on thermal conductivity of various alloying elements. So here we can see that if you increase silicon, the thermal conductivity decreases. If you increase the amount of manganese and chrome, you can decrease thermal conductivity. Molybdenum and vanadium don't have a lot of impact on the thermal conductivity, so at any rate, if you look at these ranges and the properties that you can get at specific ranges, they've selected materials that are, you know, kind of in this range. So we've got, in watts per meter degree Kelvin, you know, maybe something that's hanging around the high 30s for thermal conductivity.
In order to attend this webinar, you must be a member of NADCA Membership Plus. With Plus membership, you gain access to an online engineering community, exclusive quarterly technical webinars, downloadable NADCA publications, and access to exclusive applications. Residents of North America are eligible for Individual Membership Plus. Current NADCA individual members and employees of NADCA corporate members can upgrade to Plus for just $21. If you are not currently a NADCA member, the cost to join is $106. For more information, please visit www.diecasting.org/membership/plus. NADCA video news and information is brought to you by the following sponsors: